what we have been doing the last two classes. So I introduce you a binomial theorem. But very first of all, so I present you something like this, like very complicated one, right? But this one at the end you see this one becomes simple. So here is the binomial expansion. So a plus b to the n. So equal a to the n times n, a to the n minus 1 be the first power. Then we put the power 4b is in red, okay, in red, okay, in red, and so on. Okay, then finally you have somewhere n times n minus 1 times n minus 2 dot 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 times n minus k minus 1. Okay, so a to the n minus k, okay, time b to the k power and divide by k factorial. Okay, at this moment, don't worry about this one. I just put this one, and at the end, I will connect to the look like very complicated formula. Okay, now beginning the step here to get there. Okay, first of all, we start with the property of the Pascal. We call Pascal triangle. Let's put n equals 0. Okay, so you have a plus b to 0 equal 1, right? I put 1 in the middle for some reason. Because anything raised power 0 to 1. So this is n equals 0. I put 0 here. How about n equal 1? So I have a plus b to the 1 power equal a plus b, right? Okay, a plus b is 1 equal a plus b. How about n equal 2? So a plus b squared equal, remember, a squared plus 2ab plus b squared. So that's what formula you learn in algebra 2 up to a plus b cubed. The formula you learn up to a plus b cubed only. Okay, now we extend to any n can be 100, 1,000. Okay, n equal 3. So a plus b 3 by the formula we learned from algebra 2 equal a cube plus 3a squared b plus 3ab squared plus b cubed. Then do two more. So you have a plus b to the fourth power when n equal 4 equal a to the fourth power plus 4a cube b 1 to the 1 power plus 6a squared b squared plus 4ab cubed plus b to the 4th power. So now in the class we already observed that is this one is symmetric. One thing we observe. Secondly, the degree of a descending 4 become 3 become 2 become 1 become a to the 0, and b ascending b to the 0 power here, which is equal 1, then 1 2 3 4. Okay, so also this one symmetrical over this one will look like a triangle, right? So this one mark the coefficient here, let me put the coefficient in red here. Coefficient here is 1 1 1a 1b. This one here 1a squared 2ab 1b squared, then 1a squared 3a squared b 3ab squared 1b cubed, and 1a 4a cubed 6a squared 4a and 1b. So now you see this one's another observation we make is when you have 3 degrees, you have 4 terms. And then for the symmetry in the middle, you need to do only 2 terms and you flip this one, reflect this one, reflect this one. Symmetrical order. So if you have even term, 4 terms, 4 degrees, you have 5 terms. 1, 2, 3, 4, 5. Therefore, this one has to be in the middle. Then you work halfway. Then from here you put the coefficient and you can get the answer quickly. Okay, so next one. If you keep your observation, you erase all the black one here. be only the red number. Okay, red number only. Red number only. So also you see that when you have 3 degrees, 0 and 3 degrees, 0 also 3 degrees, you add 1 plus 2 equals 3, 1 plus 3. Always, each of the terms have to be 3 degrees. Okay, then erase this, erase this, erase this, and erase this. Now, next one, we see the number, the long number is the sum of the top two top number, 1 plus 1 is 2, right? Right? And 3 equal 1 plus 2 here, 2 plus 1 equal 3 right here, and 2 plus 1 equal 3, and 1 plus 3 equal 4, 3 plus 3 equal 6, 3 plus 1 equal 4, and get 1 over there. You can see that? So not discovered. And also you can see another thing is the other property, I think, if you add from the left to right, you get 1, then you get 2, and you get 4, and you get 8, and you get 10, 16. You see the pattern? This one looks like you have 2 to the n power. Can you see that? So n equals 0, you get 1, n equals 1, you get 2, n equals 2, you get 4, n equals 4, you get 16. A lot of things you can observe, and maybe sometime, just for the observation skill you develop in my class, sometimes it doesn't apply anything, right? But we get curious about, put a question about whatever you can see, okay? So that is a good thing. For example, if you want to find a plus b to the fifth power, right? If you want to expand a plus b to the fifth power equal 1, so you should do this on the fourth power right here. You have 1, 2, 3, 4, 5 terms. Fifth power, you have 6 terms. So you start with 1, and 1 plus 4 equals 5, and 4 plus 6 equals 10, and you have another 10 because fifth power you have 6 terms. You don't have to be in between, 3 here, 3 there, then a copy 5 here with her, look at that, and 1 here. So this one, the first one have a to 1a to the fifth power. Now we have 5, a going down 4 to the b, then you get plus 10 a to the cube b squared. You see the sum here, always 5. 4 plus 1, then go down 5, 4, 3. Then you go, because you have 5 fifth power, and you have 6 terms. That means you don't have to be in between 1, 2, 3. Now you copy 10 here, then you go down a squared b cubed, and you copy 5 here, because the symmetry thing, right? Then you go down a b to the fourth power, finally get 1 over there, b to the fifth power. So that is how you use the Pascal triangle to write a term. Okay. Now, if I give you a plus b to the 20th power, then it doesn't work, and you have to keep working to 20, right? So then we have to have another way how to do it, okay? Another way how to do it. So I try to keep this one because I want to match this one with that one. The crazy, formula, okay? Yeah. The book doesn't show this one, but I'm going to show you this, how to apply this one to this one at the end, next video. Okay, now I introduce the binomial coefficient. Okay, how about I mark here? I copy this later on. The binomial coefficient theorem. Okay, I want to go straight from here, and the coefficient belongs to that. That I go straight from binomial theorem. So if you have a plus b to the n power, so the coefficient here in red here, the coefficient in red here is saying like this, n0. Okay, a to the n, b to the 0 power. Okay, that is the binomial theorem. So the second term is n and 1. Oh, let's use this apply in n. So the 0 here in red is go with b, okay, because the theorem says so. later on the red one can go with A. So that is different story. So let's start with this. So 1, so equal A. I'm sorry. Now you go down one degree, right? So you have n minus 1, which is marked into this one, and b to the 1 power, and plus then n2 or a n minus 2 b squared, and so on. Okay. So now next one, what does this mean? Okay, so that is we go and we start with the notation that is this notation here. So I have n to the k number k here. What mean by this? Mean equal n factorial over k factorial times n minus k factorial. Okay. So now, what mean by n factorial? N factorial is, the meaning is n times n minus 1 times n minus 2 times n minus 3 and so on until 1 in the dot in the end, right? Or so n factorial, how about 10 factorial? So 10 factorial equals 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 1. You see eventually this one here. So this one is 10 times 10 minus 1, which is 9, and times 10 minus 2, which is 8, 10 minus 3, which is 8. So this is a definition of factorial. Okay, factorial. So the notation like and like exclamation mark. Okay. So then you discuss about 0 factorial. So then we know that the 0 factorial equal 1. Okay, it's not make it up. Okay, this one we have to show why 0 factorial 1, right? In our class we don't take anything for granted. So then we use the definition to show why 0 factorial equal 1. So we start with n plus 1 factorial equal what? Equal n plus 1 times n factorial, right? This one 10 factorial equal 10 times 9 factorial, right? So if you divide by n plus 1, so you have n plus 1 factorial divided by n plus 1 equal n factorial. Now you substitute 0 here. 0 factorial equals 0 plus 1 factorial divided 0 plus 1 gives you 1. So therefore we conclude that 0 factorial is 1. Okay, now almost there. Almost there. Yeah, we go over everything. So now we apply. Okay, after application here, then we done for the theorem. Now, if I want to expand a plus b to the 7th power, yeah, officially you go with the theorem say, okay, equal 7 with the n here, the total here, n 0 degree for b. So a to the 7, right? You start with a to the n. And obviously b to the 0, b 0 equal 1, so we don't need to write down. Okay. Then the next one, 7, 1. So a to the 6, b to the 1. Plus 7, 2. A to the 5, b squared. So in this case now, this number here go with b, not go with a. But remember, 7, if you go with a, the same thing, 7, 1 equal 7, 6. So let's prove it. So 7, 1 means 7 factorial divided by 1 factorial times 6 factorial. So notation of this one is going to be like n factorial divided by k factorial and n minus k factorial. Okay. And okay, so you add this one and this one always equal n. You add 6 plus 1 always equal 7. So now we apply this notation here. 7 factorial, 1 here, 1 k factorial, 1 here, and 7 minus 1 equals 6. So then you have, what is this equal? Equal 7 times 6 factorial on the top, 1 factorial, 6 factorial cancel, you get a 7. Then this one equals 7. Okay. I'm tied up this on my chart paper somewhere else, right? So this one here, we're going to have this one here 7. A to the 6, B to the 1. How about 7, 0? 7, 0 equals 7 factorial over 0 factorial. And 7 minus 0 equals 7 factorial. Cancel, you get 1. So you get 1 a to the 7. Okay. So next one. So don't work here, you have to work somewhere. So we find this one here, what is that? So you have 7 factorial over 2 factorial times 5 factorial equals 7 minus 2 equals 5. So the sum of them over equals 7. So then you have 7 times 6 times 5 factorial. Stop there. And because you have this 2 factorial times 5 factorial, you cancel this one. 7 times 6 equals 42 divided by 2 is 21. 21 a to the 5th b squared. Now I try to apply, I do one more. Because 7 degree means have 8 terms. So I do 4 terms here, and I do symmetrical, I move over there, then I don't have to work harder, right? So the next one, I do one more, 7, 3. Okay, a to the 4th b cubed. The sum of this one over equals 7. Can you see that? Now I work on a scratch paper. Okay, so what means 7, 3 here is equal 7 factorial over 3 factorial times 4 factorial. So then we expand 7 times 6 times 5 times 4 factorial divided by 3 factorial times 4 factorial. Cancel that 4 here. And 3 factorial means 3 times 2 equals 6. Cancel, that's 6. 7 times 5 equals 35. Then again, plus this one here equals 35 a to the 4th power b to the cube. So far so good. 1, 2, 3, 4. So 7 degree. I have 8. Therefore, 4 here. Then I have another 4, right? So then I did on a symmetric in the middle. So I have 35 a cube going down 1, go up 1, and you get 21. Go down 1 again, go up 1 again, and I get 7 a b to the 6th power. Finally, I get 1 b to the 7th. Okay, we apply the binomial theorem better than Pascal in the case if you have this one big one. Okay, you cannot just keep copying, you go straight into the theorem. Also, the theorem tells you exactly if you have like a plus b to the 7, you want to find a term with to 100. If you want to find a term with b to 99, so then you can go straight to b to the 99 and a should be 1 and this one should be 199. So you can have straight into the in the term you want with 100 here. So versus if Pascal you have to go boom, like the whole day to get to 100 degrees, right? So this one here, application of binomial theorem a lot nicer.